To further continue, after the introduction of functional safety and cyber security, we are going to see in this lesson how or the integration of functional safety and cyber security into Autosar. Now, Autosar stands for Automotive Open System Architecture. It integrates functional safety and cyber security principle directly into its architecture or stacks to support the development of safe, secure automotive systems. Now let's break down how this integration works across both the classic and adaptive platforms. First is the functional safety integration. The first function in ISO 26262 and Autosar aligns closely with ISO 262, the international standard for automotive functional safety. Now key mechanisms in Autosar for safety. Memory, first is the memory partitioning. All right. So when it comes to safety, what is the most important mechanism in AutoSAR? First is memory partitioning. It isolates software components to prevent unintended interference. It also supports fault containment and recovery. Next is timing monitoring. Uses watchdog timers and supervised entities to detect timing violations. It ensures tasks execute within defined time videos. So this is extremely important because tasks must be executed within the defined time videos. And next is logical supervision. Now coming to logical supervision, it monitors the software behavior and control flow, detects anomalies in execution logic. End-to-end protection ensures data integrity across communication paths. So in the entire communication path, right from the port, right from the scanner tool, there are plenty of points where cyber attack may happen. So the data integrity across the entire communication path must be maintained. So it uses checksums and sequence counters to detect corruption or loss. So, and when it comes to hardware diagnostics, includes RAM tests and core tests to detect hardware faults. Supports safe startup and runtime monitoring. These features are built into Autosar classic platform, making it deal for safety critical ECUs like braking, steering, and powertrain systems. Okay, so all these features which I above narrated, they are inbuilt in Autosar classic platform, and that's the reason Autosar classic platform is ideal for safety critical ECUs like braking, steering, and powertrain systems. As anybody with automotive knowledge knows, these systems are extremely important as far as safety is concerned. Cyber security integration. Next is the cyber security integration. Autosar also supports ISO SAE 21434, the standard for automotive cyber security. Okay, in the previous lesson I mentioned about cyber security. Now we will see how what are the features in Autosar, what are the inbuilt inherent features in Autosar that support the automotive cyber security. The first is secure boot and secure flashing. Verifies software authenticity before execution, prevents unauthorized firmware updates. Now, next is cryptographic services, crypto service manager. It manages the encryption, decryption, and key handling, interfaces with hardware security modules. Now, when it comes to firewall and intrusion detection, monitors and filters network traffic, detects and logs suspicious activity. Okay. Now coming to secure communication, communication adds message authentication, integrity checks, and protects in-vehicle and external communication. Last but not the least, security event logging. So it records security-related events for audit and analysis. Okay, so sometimes during the security audit, this recording of the security-related audits is important. So these mechanisms, which are inherently built in Autosar adaptive platform, which is designed for connected and autonomous vehicles. All right. So hope you understood. These are all the various features in Autosar which help the cybersecurity integration. Now coming to harmonizing safety and security, Autosar enables co-development of safety and security by first supporting ASIL decomposition and freedom from interference, allowing shared resources between safety and security modules, facilitating traceability of safety and security requirements. This is important. As far as this development during V model is concerned, facilitating the traceability. There should be a proper traceability between the requirement and the final result. Next is enabling risk assessments like HARA and TARA. Okay, so when you harmonize the safety and the security, an AutoSAR is perfectly capable of developing or ensures the coexistence of both safety and security by the following features. Okay. Now, when it comes to real life use case and designing an AutoSAR compliant software stack, first let's walk through a real world use case and design AutoSAR compliant software stack that integrates both functional safety and security and cyber security based on the project for battery management systems in electric vehicle. Okay, first is the use case battery management BMS for EV. A tier 1 automotive supplier needed to upgrade their BMS ECU to meet ISO 26262 ASIL C safety requirements and support CAN FD diagnostics using Autosar classic platform. So, and this is the use case we are going to discuss. What is the main key requirement as of BMS? Monitor battery voltage, temperature and current, ensure safe operation during the fault conditions, support UDS diagnostics, enable secure firmware updates and integrate with existing the tool chains, whether it is Renesas CS Plus or Canalizer. So these which I narrated just now, which I outlined just now are the key requirements. Now how do we design the compliant Autosar compliant software stack? Okay, now here's how the stock was architected to meet both the safety and security goals. First, when it comes to application layer, the software components for cell voltage monitoring, thermal management, fault detection and reporting, developed using the MISRA C guidelines for safety compliance. Okay, so first you start with the application layer. I'm just giving a brief overview. Going into detail is well beyond the scope of this particular session or of this particular training of this training course. But to give a brief overview, so these are the various aspects for which software components are monitored. Next, when it comes to runtime environment, which is a very important layer of the AutoSAR architecture, mediates communication between software components and basic software components. It ensures freedom from interference between safety critical and non-critical components. Okay, so in this table, we will see the layer, the modules and the purpose. When it comes to the layer, system services, operational system, watchdog, diagnostic manager, task scheduling, fault logging and safety monitoring. Next is the ECU abstraction. ECU abstraction is ADC, PWM, SPI drivers. These are the important modules as far as the ECU abstraction is concerned, and the purpose hardware abstraction for sensors and actuators. Coming to microcontroller abstraction, CAN FD GPIO timer. All right, so these are the three modules of the MCAL. So the purpose is direct access to Renesas microcontroller peripheral. So these modules, through these modules, access to microcontroller peripherals is achieved. Now, most important, in my opinion, okay, the opinions may vary, but in my opinion, this is a very important stack, most important stack, communication stack. The CAN interface, the PDU router, the UDS, these are the modules which support the ISO TP UDS diagnostics over CAN FD. Now coming to the crypto service manager, secure boot message authentication. Okay, so in this layer of crypto service manager, these are the important modules and they ensure cyber security compliance ISO SAE 21434. Now, talking to the safety integration, embedded high-tech's safety library for ASIL-C compliance, RAM, ROM tests, watchdog supervision, and fault recovery routines. Next is the security integration, secure bootloader with firmware validation, role-based access control for diagnostics, seed key exchange for unlocking UDS services. Okay, so hope all of you got how the various aspects of security and safety are inherently covered within the Autosar stacks. To further elaborate, what are the various tools and technologies used? Comaso BSW stack, which is a pre-certified Autosar module, Renaissance CS Plus, IDE plus debugger, and Samdia CAN analyzer diagnostic validation, GNU GCC toolchain, cross-platform compilation, UDS ISO 14229 plus ISO TP diagnostic protocols. Now, coming to the outcome, the reduced integration cycles and testing effort, real-time fault isolation and diagnostics. So this is a very important outcome, real-time fault isolation and diagnostic. And coming to the scalable architecture for future BMS enhancements, and fully compliant with ISO 26262 and Autosar standards. Okay, so these are the various outcomes of making sure that Autosar stacks have Autosar stacks are equipped with safety and security. Okay, thank you.